Alright guys, so it's been a long time since I've used my my CNC router, but this is the material that we're going to be using. It's a bit of Mirandi. It's 40mm thick. So I've already cut it to 160 by 160, and what I'm going to do is mark it down the middle and just saw cut it, and then we'll attach it down onto the table here, and we'll face it down to the required thickness. So we'll get set up with that next. So yeah, I'll get that cut first. I'll go ahead and get that mounted, and we'll start running some code on it and see if we can do something. But yeah, I've got to do a bit of cleaning up in here first. I sort of jumped everything in here when I was doing the work on the shed slab, lifting it up. So I've actually lifted this up a fair ways too to get that squared up. So this shed is also sinking. So I've got to get the core man back, and we'll core some holes through this, and I'll sink down, put some concrete columns in, and we'll jack this up level as well. Alright, well we'll come back once we've got this all set up, and we'll see how we go with that code. Alright, I'll catch you soon. Alright, I'll just go handheld for a little while. This Mirandi block I've cut in half with a panel saw, and it's got a fair old bow on it. You can sort of see it there, a bit of rock. So what I'm going to need to do is to I'll glue this down onto the wasteboard, and then I'll just run a 20mm cutter over it just to get it squared up nice and flat. Then we'll flip it over, do the same thing. We'll take it down to size, which is going to be 14mm. Then we'll zero it out, and we'll start our machining. So a little bit about the machine. I built this back in early 2000, and it hasn't changed much. Originally had all thread screws on it, but made it a little bit more funded. I put some Acme screws in, and I got a ball screw off eBay for the Z-axis, and it's just running off stepper drives, 425-inch ounce stepper drives. The whole thing runs in bright chrome marbrite bar. It's just very simple, just with some roller bearings is all I've made, just some linear tracks up, and I can adjust these up and down in the middle, and I can adjust the ends around as I need to get the unit running square and parallel, and that system works really well. And yeah, very tight tolerances it can hold. Same up inside. The nuts, I've got double nuts there, and I just tension them up against each other. So I made up a tap to actually tap all those nylon blocks out, and that works really well. And same underneath. I don't know if you can see it under there, but same thing underneath there with the nuts working against each other to take out the backlash. So like a lot of us, I use the Mach 3 program for my delivering the CNC code to the machine. The drives I've got on this are the Gecko 251s. I originally started out with the old Oakley chopper drives you had to build yourself, and spent most of the time there with a bit of freeze spray on the MOSFETs, because they kept overheating and the steps started going out, and it was an absolute pain. And I went to a competition to see if I could win some of the early Geckos. They're the 201s. So I won 3 of those and retrofitted it in, and since then I've put the 251s in the box with a power supply. So that all sits down inside there. And it's just a very cheap PC that I've got that runs it. Took the parallel port out of it, which is needed for the Mach 3 program. So as I said, I built this back in the very early 2000s, and it's sort of had a little bit of evolution since then, but basically it has changed, has remained the same. Righto, well I'm going to set up, and I'll get these linked across the top. As I said, I haven't run this machine for 3 or 4 years, so I've just run the code for machining these, and it ran out about an hour and a half it ran for, so that's not too bad. I had a few issues with the coding initially got those ironed out, and hopefully, touch wood, we won't have any issues, but you never know. Well, before I do start, yeah, I've got the Makita router that I run on here for the heavier stuff, but if I'm doing really fine stuff, I've just got an old Dremel I picked up from a yard sale that I clamp on. I'm just going to adapt the ring up underneath there I take out, and this will slide straight in, and I can nip that up. Cutters, that's what we're going to be using for cutting, just a 1/4 inch flat router bit. And then for the finishing, I actually use a burr. Little 1/8 burr is what I use for the finishing. So there's going to be one tool change in this. And the machine does stop on the M6 to allow me to do that tool change. So unlike before when I was running visual mill, I did have to, because I couldn't modify the post processors, I used to bring it home and just spend a bit of time re-editing the G-code to get it run on this machine. So I had a list of little parameters I had to put in each time and a few things I had to change, but that worked well. But this one, it's gone in first time since we've got over the little idiosyncrasies, and it's all a learning curve. So we'll see how we go with this new program. Alright, as I said, I'll get this set up, and I'll quickly just get this a lick across the top and get it all squared up, and then we'll bring it down to thickness, get that all on the board, and we'll come back ready for the machining. Alright guys, let's see how this goes. So at the moment I've just zeroed off on the two edges. I'm just going to come down and zero off the Z-axis, and I just do that with a touchdown on a piece of paper. There's all sorts of probes you can make, but for what I've done in the past, this has done quite nicely. That's just dragging there, so that's where I want. Alright, so we'll zero out that Z-axis. Now my router's playing up a little bit. There's obviously a lot of dust in the armature there, or somewhere the contacts aren't quite mating, so I've just got to be careful with this. So we'll page up. Right, so the cutting profiles we're going to start off with. Well, before I do start, I must tell you I've put some screws just here in the corners, just as belts and braces. That super glue is held really well, but just belts and braces to make sure that this doesn't move. So the first one we're going to do is do a pocket, which is going to machine out the bulk of the material but leave our little raised boss in the middle. Then we're going to do another pocket command to actually machine out the guts where the spokes are. After that we're going to do an outside contour, which is the outside diameter of the flywheel pattern, and I'm going to put tabs into that so that holds it together. After that we're going to do two parallel functions, so one at 90 degrees and one at 0 degrees. And that's where our tool change will come in. So I'll put in the 1/8 ball mill into that, or ball burr into that, and then we're going to do what's called a ramp, which will machine the outside parameter, or perimeter if you like, giving us that taper that we need. And I'm going to do an inside contour, so I'm just going to try out some different machining type arrangements, and we'll see how they work out. But we're all set to go. We've got the code up. We won't watch this all the way through. I'll come back and just do snippets of it. We'll see how we go for starters. Once again, just used a bit of paper. And that's just dragging now. So I'm happy with that. We'll zero off that Z-axis. And we'll get things going again. Right, we've come into a problem. The cutter router's just totally packed it in. So it's a pain because it's right on the last finishing passes. So what I'm going to have to do, oh dear me, alright, I'm going to have to strip this down, give it a birthday, try and get it back and going again. I'll cut up another bit of stock for this and we'll go at it again. Little mistake I did make with the programming, and it's just one of those click boxes you got to select, is that on the parallel passes it's not coming all the way down, creating the taper. I would have picked it up in the silhouette pass, but it would have been nice to do it now. But I'll certainly do that in the next one we make. But in the meantime, we'll get this stripped down, and what I'll do is I'll get it put back together and we'll get the machining roughly back to this stage again, and we'll come back and film it again. Alright, sorry about that guys, but yeah, we'll get back to it soon. Alright, well the purpose of today wasn't to strip down and repair my die grinder, but that's what it's looking like. I'm going to give this a blowout. It's just chock-a-block full of dust. This thing's been running for, well, when I was doing pattern making, pretty constant for 10 years. Yeah, it looks like the brushes are down to nothing, so I'll give this a blowdown, and we'll whip the brushes out, and we'll just have a bit of a look at those and see how we go about getting some replacement brushes. But yeah, they look like they're down to nothing. So I'll just go out and give this a blowdown with some air, get it all cleaned out, and we'll come back and get those brushes whipped out. Right, so that's one brush out, and that's yeah, there's hardly anything left on that. We'll get the next brush out. That is a little bit tricky to get the little connectors off. It's got to be very gentle that you don't break anything else while you're trying to lever these little things off. It's always the one you're showing people that's the hardest one to get off. There it goes there. So that's off now. Right. Let's just try and get that out. Just got to be careful here. There we go. And I can tell you, there is nothing left of that. That is, actually that's arcing across pretty bad just there too. So we might just zoom back a bit and we'll try and pull the body out. Right. What I always do is just give a witness. There it goes. Oops. Right. That's arced across there real bad. I might set that up in the lathe and give that just a very, very light lick on that. It's got quite a bit of wear on it there. Alright, so in the meantime I need to order some new brushes. So we'll leave this little rebuild for now, and I'll come back when we're going to clean all this up anyway, and give that a little lick in the lathe. I don't think the bearings are too bad. I think we can live with those. The rest of it, yeah, we'll just set that up and we'll just give that a little shaft and grab onto there. We'll just give it a little lick in the lathe, I think. Alrighty, we'll come back when we've got some spare parts ordered or here, and we're going to give that a little tickle up. Righto, we might as well come out now and quickly do this. So I've got it mounted in the tailstock up at this end here, and just in a collet that I'm holding in this D14 to ER32 collet adapter. That's the surface there we're gonna clean up, which is just, yeah, it's pretty roached out. A lot of arcing across there, so we'll give that a very quick lick. Righto. Just go through and take those little burrs out, but that's it done. So that's a beautiful finish again. Alrighty, I'll take that out and I'll have to order these brushes, and we'll come back when we're going to get them back into play. Alright, I'll see you soon. Righto, so I've got new brushes from my local Total Tools store, so we've got those. That's the ones that came out. As you can see, they're absolutely roached out. That one's almost disintegrated. So you can see that little commutator down there, it's all been cleaned up. We did that yesterday. So now we've got to get these back into place, and I've changed the ones out on my grinders in the past, and the easiest way I found was to make up just a little hook and a bit of wire, a paper clip or whatever you can get your hands on. And there's quite a bit of tension on this little thing. Just hook it up and poke it out of the way. It's the way to go. There's no left hand or right hand on those things. There's the, it's going to be the closest. Alright, so we're just poking back down. And try and spear him back into place. And that's it. A little spring, pop him back on again. That's the same show on the other side. Fingers crossed. That's it. We'll go again. Right, we can get back into Emma's flywheel. So I've made a few changes on that code, on that program. So we'll get set up again and we'll go through those. Alright, happy with that? So those replacement brushes cost me about $20 down at my local Total Tools, and you get them online for about $10. But I'm getting patient, we'll get the thing going again. So, good result. Alright guys, we'll see you back out there. Okay, so we're standing on the outside of where I've got the CNC router. We're sort of back to where we were last time. I've changed some of the coding around and some of the machining operations around a bit, and it seems to be doing a lot better. And I've also changed the material, so I can get that up in front. I've got some mahogany that I'm using, and this stuff is as hard, and it has been extremely well seasoned, so I don't expect that to move in any way, shape or form. And I've done quite a few patterns with mahogany, and it gives a really shiny finish after it's been finished. So with the other cuts I was doing too in the Marani, I had a 1/2 mil step over that I didn't realise, so I've cut that back to 0.3 just to make the machining an awful lot smoother. So we'll go in now and we'll have a look. So I've got it closed up. I've got this whole shed, I've reclad it inside and soundproofed it, so it makes it a little bit quieter for the neighbourhood. But we'll go and have a look. Alright, so it'll come out, so yeah, really smooth glass-like finish on that. So I've got another 90-degree pass to do on that. After that, you've also noticed the tool is actually now running down the slopes, cutting the taper on all the slopes, and running the full diameter of the wheel now. So yeah, it should come up really nice, that one. But geez, it was hard to cut that in half with a saw. It just about killed me. So yeah, I don't expect that to move. It should be a very stable pattern. So alright, we'll come back when we're sort of getting close to the finish, and we'll have another look and see how it's progressing. Okay, so now we're cutting at 90 degrees to the previous parallel cut. After this cut, we've got a contour cut inside, and then we've got what they call a ramp cut on the outer diameter of the flywheel. So let's go and have a see how that's looking. Alright, that's looking beautiful. Looks like a piece of furniture. Beautiful finish. Once you run the contour on this, I don't think we're even going to have to sand this. It's as it comes off the machine, it'll be finished. Alright, we'll come back later on and see how the progress is run. Righto, we've just completed our cut, and hopefully, there it is. that's it finished. It's a very pretty little flywheel, I reckon. Alright, well, all I'm going to do is just touch that with some sandpaper just to clean the little daggy bits off the bottom, but other than that I'm not going to touch it at all. It's got a nice shiny mirror finish on it, and that ran for about 2.5 hours, that coat, to cut that little flywheel out. So we'll do the other side next, and I'll show you what the two halves look like when they go together, and then I'll get them posted up to Emma. Alright, great result, very happy with that. Alright, I thought I'd just, I'm just in from the workshop. All I've done is just a little bit of emery cloth. I've just gone over the back of it and just taken off the little furry edges. So we're going to leave it like that, and I'm looking at this and I can't see any machine marks in that at all. That is just a beautiful shiny finish straight off the CNC router. So, and the same practice would go for 3-axis milling machine, which I have got the bones of one there that I'm going to retrofit and turn into a CNC mill to go with my little CNC lathe. But I don't know if you can pick up the shine on that, but that is just shiny. And as I said, that's out of mahogany. This is hard stuff, and it's been seasoned for over 50 years. This plank I got off a good mate of mine that had been sitting in his shed for goodness only knows how long, and I've had it outside for probably the last 10 years. So that's the one that was done in mahogany, and that was the one we did in the Morandian. The Morandian's a lot softer and it's a lot furrier. Look, that would come up really well just on its own, but it probably wouldn't have the durability as what this this mahogany one's going to have. So, and it's a really pretty little flywheel. It's what I call fine scale. It's just got a nice little pretty shape about it, and some nice little detail through it. So we'll do the second half, and yeah, we'll get these away. But I'm not even going to paint these, I'm just going to leave them as they are, and I can put a coat of urethane on or something. But yeah, alright guys, we got there, and as I said, I've learned a new program and learned a few idiosyncrasies. I probably wouldn't go the same machining pattern the next time round. I probably didn't need the two parallel passes. I could have done one parallel pass and then just come back with the finished contour pass on the inside, so I can cut the time down quite considerably on that now that I know what each of these machining operations does. Alright guys, I'll leave it at that, and we'll see you soon.